Hello student, this is Darasa Online. My name is Edgar Mshana. I'm teaching basic applied mathematics. In this part of presentation, I'm going to share with you some review questions concerning to functions. And in functions, we are going to review questions in the subtopics of quadratic functions. But again, we have step function and the rational function. Last one will be composite functions. Join with me, my dear student, till the end of this presentation. Welcome. So, my dear student, we're starting with the review question 1. That will be a step function question. Now, the question says, given the function f of x is equal to x squared plus 5x plus 7. Now, from this point, we find A, that is the maximum or minimum value. That is A. But again, B, we have to find the axis of symmetry, the axis of symmetry. Now C, the turning point. We have to find the turning point. That is the turning point. And the last question will be to find domain and range. Now that is our question. We have the function f of x, that is a quadratic function. Then we are supposed to find the maximum or minimum value. Then the axis of symmetry. Then we have the turning point. And then to wind up with the domain and range. Now, my dear student, how do you finding the maximum or minimum value for the given quadratic function? First, remember, the form of a quadratic equation is written as ax squared plus bx plus c is equal to 0. Now, if, that is if a is greater than 1, that is when a is greater than 0, then we have a minimum point. That is, we have a minimum value. But again, if a is less than 0, then we have the maximum. That is maximum value. Now let us see our quadratic function. So a here is equal to 1. Now a is greater than 0. That means we are going to find the minimum value because a is greater than 0. So in this point, we are going to have y minimum, that is y min, called y min, which is given by the general formula, that is 4ac minus b squared over 4a, that is over 4a. That is your general formula. So we have a is equal to 1, that is 1. Again we have b is 5, so we have 5, and c is equal to 7. So my dear student, we just substitute these values in our general formula. Therefore, y min will be equals to 4 times a. Our a is 1 times b times c. C is 7. Then this one minus. Then we have value of b. So b squared will be 5 squared over. Then we have 4a. That is 4 times 1. Now, my dear students, we are going to have the following result. Therefore, y min will be equals to we have 4 times 1 times 7. That will be 28. We have 28. Then minus, here we have 5 squared. That is 5 times 5, which is equal to 25. Now over, then we have 4 times 1, which is equal to 4. Therefore, y mean is equal to 28 minus 25, which is equal to 3 over 4. So that is A. So y minimum is equal to 3 over 4. But again, for B, we are supposed to find the axis of symmetry. The axis of symmetry. So B, axis of symmetry. Symmetry, that is XC, is given by negative B over 2A. That is the general formula for finding the axis of symmetry. Remember, we have values for B, but again for A. So we just substitute direct here by saying XC is equal to negative. Then we have B. B is 5 over, then that is 2 times A. So it is 2 times 1. That is 2 times 1, which is equal to negative 5 over 2. Therefore, the axis of symmetry XC is equal to negative 5 over 2. Now, my dear student, we proceed with the C. That is the turning point. So C, need to find the turning point. We call that is turning point. But remember, turning point is given as a coordinate. So that is XC, y, which is equal to, for XC, we recall the formula for axis of symmetry, which is negative B over 2A. This one, comma, because it is a coordinate, followed by Y. Y, we are taking the formula for minimum. That is 4AC minus B squared over 4A. So it will be a coordinate. But remember, already we have this value, negative B over 2A, which is equal to negative 5 over 2. So this one is negative 5 over 2, comma. Then again, for the second value, that is y minimum, the value of y minimum is 3 over 4. So y minimum is 3 over 4. Now, my dear student, we have the turning point. So that is C. Now we are asked to find the domain and the range. That is the domain and range for our quadratic function. So for the case of domain and range, that is D. So D, we are supposed to find domain and range. Now let us start with the domain. Now what is domain? Domain refers to first entries or X values. So if it is X values, we are talking about the quadratic function. For quadratic function, domain is the set of all real numbers of X. Therefore here we just say X such that X is a set of real numbers of X. That is real numbers of X. But for the case of range, that is for quadratic, range refers to y values or second entries. So y values, this one should be greater than or equal to the minimum value. Remember, the minimum value is given by, that is 4AC minus B squared over 4A. That is how to find the minimum value of y. Now range for quadratic function will be, that is y is greater than or equals to. Remember, we have this value, already we have this value, which is equal to 3 over 4. That will be greater than or equal to 3 over 4. Now, my dear student, that is how to solve such kind of equation, quadratic function, when we are asked for maximum or minimum value. But again, the axis of symmetry, the turning point, and also to wind up with the domain and the range. Now, my dear students, let us proceed. Let us proceed with the second part, that is we call step function. This time we have step function review question. This time we have the step function. So we have a review question for step function. Now that is question 2. Remember, we are making revision on the topic of function. So for the case of our step function, we have a question which says draw the graph. Draw the graph of the following step function. That is step function, and the state domain and range. So the step function says f of x is given by, so we have -4 if x is less than -2, but again we have 2 if -2 less than or equal to x less than 3. And the last one is 5 if x is greater than or equal to 3. So, my dear student, you have the step function, and in this step function, they need to draw the graph followed by to state domain and the range. Now, proceed as follows. So, since it is a step function and we need to draw the graph, you prepare x and the y axis. So here you need to prepare x. So starting with y, that is y axis. Of course, followed by x axis. Call this x axis, and the origin, indicate the origin, that is 0. Now we have values for x and the y. So that is so that is our x and y axis. Now remember, in this step function, the first entries, which are -4, +2, and 5, these are y values, or we call range. And of course, the second values, these are x values. Now starting with -4, this is y value. So where is -4 in our x and y axis? So here we have -4, it is this one. So for the case of x values, we have a condition which says x is less than -2. So values of x are less than -2. So where is the -2 for x? It is found somewhere here. So we need to find the point of intersection between x value, which is -2, and the y values, which is -4. So the point of intersection will be somewhere here. So this will be the point of intersection where -4, that is of y, and the -2 of x meet. So here we have this inequality symbol, that is less than. Remember, my dear student, for inequalities less than and greater than, we use a small circle to represent these inequalities. But for inequalities less than or equal to, and greater than or equal to, and even equals to, equal sign, we use a shaded small circle. We have a small circle which we just shade it. We shade the small circle. Now here we have the inequality symbol less than or equal to. So of course we are going to use our unshaded circle. So here we just draw, we sketch a small circle like this, and then we interpret this condition. X is less than -2. We indicate values of x which are less than -2. So values of x which are less than -2, they are in left hand side. So we do like this. So this is the first condition. So we proceed for the second condition. We have +2. Remember, these are y values. So 2, that is +2. We just find where is +2. So +2 is somewhere here. So that is +2, value of y. Then the condition for x values, starting with -2 to 3. So it is the interval from -2 to +3. So where is the -2? -2 is somewhere here. So it will be here. And again we have +3. So +3 of x will be here. Now again, the second step, we are looking at the inequality symbols. So the first inequality symbol is less than or equal to, which is this one. So we just use the shaded circle. So here, just draw the small circle, and then we shade it to show that the value is included. The value is included. Then again, we have x is less than 3. So this one is obviously like this one. So we just draw a small circle without shading it. So draw a small circle without shading it. Now we have that interval of x values which are passing through +2 value of y. So we just join them by this line to show that the step function are involving -2 of x to 3, but passing through a +2 value of y. So that is step function 2, number 2, step function number 2. So number 3, number 3 says +5, that is 5, if x is greater than or equal to 3. So remember, this is value of y. So where is 5? 5 is somewhere here, that is +5. Then condition for x value, x is greater than or equal to 3. Where is 3? So again 3 will be here, that is 3. So we have 3 somewhere here. So that is 3. So for this inequality symbol, we just draw a small circle and you shade it. That is, shade the small circle. Then try to interpret values of x which are greater than or equal to 3. So we go in our right hand side. So it will be this way. This way. Therefore, we've already completed our step function graph. So this is the graph. Just write graph. A graph of f of x. Remember, f of x is a step function. So the next step, state domain and the range. Now for such kind of step function, domain is equal to, remember when you're talking about the domain, we are talking about the values of x or first entries. So x such that, so x will be the set of real numbers for such kind of a step function. For range, that is range, remember range, we are talking about the y values. And the y values are the first entries in our step function. So here y is equals to, we have -4, then again followed by +2, that is 2, and the last one is +5. So here we have 5. So my dear student, we have domain and range, and that is how to do such a kind of equation. That is a step function. We have a step function. So My dear student, let us proceed for the third subtopic, that is rational function. This time we have a rational function review question. And now the question says, again, draw the graph. Draw the graph of the function. Draw the graph of the function f of x is equal to 1 over x plus 2. And again state domain and range. So this is our question. This is our question. It is a rational function. Just look at f of x is equal to 1 over x plus 2. We are supposed to draw the graph of this function and then later on to state domain and the range. Now, before drawing the graph, we have to find vertical asymptote. There is something known as vertical. We call vertical asymptote. Or to find what we call vertical asymptote. So of course we let our function as y is equal to 1 over x plus 2. So here y is written in terms of x. So here we say put denominator. Put the denominator is equal to 0. That is, the denominator here is x plus 2. So we have x plus 2 is equal to 0. So of course we solve for x. So here x will be equals to negative 2. So this is called a vertical asymptote. The value of x which does not exist in the graph. We are going to locate this value of x by using a dotted line. So here we say vertical asymptote x is equal to negative 2. Then again, my dear student, we have another thing called the horizontal asymptote. This time we have horizontal, that is horizontal asymptote. So by using our equation, that is y is equal to 1 over x plus 2. Now this time we try to make x the subject. So yes, what we call cross multiplication. We cross multiplication. That is y bracket of x plus 2 is equal to 1. Now remember, we make x the subject. So we can divide by y from both sides. So divide by y. So here we are going to have, that is x plus 2 is equal to 1 over y. So let us shift the positive 2 in our right hand side. So we are going to have x is equal to 1 over y minus 2. So try to find the lowest common multiple for y and 1. So x will be equals to, we have y, then 1 minus 2y. Now x is written in terms of y. So again we say that is put denominator is equal to 0. So what is our denominator? We have here y. So just say y is equal to 0. So y is equal to 0, that is our horizontal asymptote. Therefore, we say horizontal asymptote y is equal to 0. Now what does this mean? That means the value of y which does not exist in our graph. So we are going to locate this value by using a dotted line. So, my dear student, you can find the y-intercept. You can find the y-intercept by using our equation. So get the y-intercept. So of course, y-intercept is when x is equal to 0, occurs when x is equal to 0. So here we have y is equal to 1 over 0 plus 2. So y-intercept will be equals to 1 over 2. So where the graph will cut the y-axis. Now, let us draw the graph. Let us draw the graph. So our graph, just try to sketch it at the graph of f of x, f of x, that is remember this is the y-axis. Of course, this is x-axis. So we start with the vertical asymptote. That is, vertical asymptote is when x is equal to -2. So make sure you indicate -2. Okay, -2. So remember, this one will be located by a dotted line. So here we use a dotted line this way. So this is what we call the vertical asymptote. It occurs when x is equal to -2. So it is a line. But this line we represent by using a dotted line. Now another asymptote is what we call horizontal asymptote, when y is equal to 0. Now where is y is equal to 0? It will be along x-axis. So the dotted line will be along x-axis. Will be along x-axis. So this one, of course, also we call y is equal to 0. Is a point where 0 is not included in our graph. But again, we have y-intercept. Y-intercept, here we have a half, because this is a half. Then we have 1. Of course, we are going to have 1.5 somewhere here. It is a half. Of course, we have 1. Then we have, that can be 1.5. Of course, we have 2. Of course, on the opposite side of y-axis, we are going to have a -1/2. Of course, that is, again, we have -1. Then, of course, -1.5. Maybe here we have -2. For the case of x-axis, we have 1. Of course, we have 2. We have 3. That way. Of course, here we have -3. So remember, we are talking about a rational function. In rational function, some of the values does not exist. So our graph will go this way. Oh, that is our first graph. Will go this way. And again, for the second one, will be this way. But will cross the y-axis at positive a half. It will cross at positive a half. So this is our graph. This is our graph. That is a rational function graph. So here the value which does not exist, one, is the horizontal asymptote when x is equal to -2. That is vertical asymptote when x is equal to -2. And another one is horizontal asymptote when y is equal to 0. Y is equal to 0 is along the x-axis. So the dotted line will go along the x-axis. So these values does not exist in our rational function graph. Now, my dear student, that is how to draw the rational function graph. But again, in our question, they said find the domain and the range. So find domain and range. Let us see how to find domain and the range. So starting with the domain. Remember, domain, we are talking about the x values. So here x will be all real numbers except when it is -2. So domain will be all real numbers except that is x is not equal to -2. So it will be all real numbers except when x is -2. X is not equal to -2. The same apply to range. That is range. Remember, range, we are talking about the y values such that y is not equal to, here we have the horizontal asymptote which is equal to 0. So it's not equal to 0. That is why we are using dotted line. Dotted line means this value does not exist. The same apply for range. Y is equal to 0. 0 is not included in range. So domain will be all real numbers except -2. And for the case of range, all values except y is equal to 0. So that is how to find the domain and the range. Now, my dear students, let us go to the review question number 4. Review question number 4. So this time, we have what we call the composite function. The composite function. So given that f of x is equal to x squared and g of x is equal to x plus 1. Now find A. We have f of g of x, and B, we have f of g of 2. C, we have f inverse of g inverse of x, and D, we have f inverse of g inverse of 5. So this is what we call the composite function. We have been given the two functions, f of x and g of x, and we are supposed to find f of g of x, f of g of 2, f inverse of g inverse of x, and f inverse of g inverse of 5. So my dear student, starting with the A, let us start with the A. A says f of g of x. Now what does this mean? That means we take function g of x, we substitute it in the variable x of f of x. So it is very simple. So starting with the f of x, that is equal to, so instead of writing x, we substitute by x plus 1. But remember, this one is squared. That means you just take the function g, you substitute it in function f of x. So the variable x will be displaced by x plus 1. So we substitute x plus 1 in variable x. So it will be x plus 1 squared. So that is what we call f of g of x. Now again, for B says we need to find f of g of 2. Remember, my dear student, already we have f of g of x. Just a matter of substituting the variable x by 2. So that is 2 plus 1 squared, which is the same as 3 squared, which is equal to 9. Therefore, f of g of 2 is equal to 9. Now let us proceed with the C. C says f inverse of g inverse of x. Now, starting with the f inverse, because here we have f of x, we don't have f inverse of x. So, for f of x is equal to x squared. So here we just let f of x is equal to y. So y is equal to x squared. Now, step 1, we exchange variables. Here we have two variables, y and x. So we exchange these variables. So the position of y, we just write x, and for x, we just write y squared. Then followed by just making y the subject. So remember here, y squared is equal to x. So just say y is equal to square root of x. But remember, we said f of x is equal to y. Therefore, f of x inverse will be equal to square root of x. Now we have f of x inverse, which is equal to square root of x. Now let us proceed with g of x inverse. Remember, this time we have 4 g of x, which is equal to x plus 1. We follow the same procedure. Here we just let g of x is equal to y. That means we have y is equal to x plus 1. So again we exchange variables. Again we have two variables, y and x. So position of y, we just write x, and for x we just write y, that is plus 1. So again we make y the subject. So we are going to have y is equal to x minus 1. But again, remember, g of x is equal to y. Therefore, we just say g inverse of x is equal to x minus 1. So, my dear student, we have the function f of x inverse is equal to square root of x. But again, g of x inverse is equal to x minus 1. Now we are in the position to find c. That is, now c said f inverse of g inverse of x. That means again we substitute g inverse of x into function f of x inverse, which is equal to, so here variable x will be displaced by x minus 1. So we have the square root of x minus 1. Now my dear student, this is what we call f inverse of g inverse of x. Now D says f inverse of g inverse of 5. That means we substitute x is equal to 5. So my dear student, here we are going to find f inverse of g inverse of 5. So we just say x is equal to 5. So if x is equal to 5, this is equal to square root of 5 minus 1, which is equal to square root of 4, which is equal to 2. Therefore, f inverse of g inverse of 5 is equal to 2. Now, my dear student, this is what we call the composite function. In this topic of function, we have reviewed some of the questions. One was quadratic function. The second one was stepped function. And then we have the rational function. And the last part was composite function. I'm sure that you enjoyed this lesson. Now, till next time, don't miss another lesson. Thank you very much for being with me from the start of this lesson up to this point. Thank you very much, and welcome again.